Hello everyone, welcome to this lecture. In this lecture, I'm going to talk about half subtractor. It is also a combinational circuit. That means it doesn't have any memory element. Okay, so let's discuss it. The half subtractor. So let's draw it. In a half subtractor, we'll be having few things like we'll be having one bit, two input. So two input, like you can take A or B or X or Y. So let's say if I'm taking one input as X, another input as Y, there'll be difference and there'll be borrow. So let's draw the structure of the truth table. So let's say difference I am writing as D and borrow I am representing as B. Okay, so what is exactly borrow and what is the difference? Let's try to understand. Let's say in binary we are having some numbers. So if you are having a number like this, let's say 1 0, and from 1 0 we are trying to subtract, let's say 0 1. So if we are doing this binary subtraction, from 0 1 cannot be subtracted until and unless we take some borrow from here. Like in decimal also, if you take the example in decimal, if you are subtracting, let's say from 10, let's say if you are subtracting 1. So here I am considering these numbers are in decimal, and here I am considering it is in binary. So this problem I am taking in binary system, and this is I am asking in decimal system. Now what is the difference? The difference, again the same thing is there. When we want to subtract 1 from 0, we cannot do, we need to borrow from here. And this place, the second place in decimal, represents 10 to the power 1. This is 10 to the power 0, that means 1, and this is 10 to the power 1, that means 10th place. So we will borrow 10 actually, and out of 10 we can subtract 1, so we will get 9 here. Okay, the similar thing we do here. So the unit place is represented like 2 to the power 0, and this is 2 to the power 1. So when we are borrowing, actually we are borrowing 2. So when we borrow 2, and 2 minus 1 will give us 1. I hope so this much uh, the logic behind the subtraction everybody understands, right? So let's wipe it out. So what is borrow and what is the difference? It should not be very difficult to understand. Now we are having X and Y two inputs, so it will be having four combinations like 0 0 1 1, and there will be 0 1 0 1, right? So let's write the difference. If it is 0 0, the difference will be 0 as well as the borrow will also be 0. But in case it is 0 1, in case it is 0 1, from 0 if you are subtracting 1, we need to borrow. So borrow must be 1. And if you are borrowing something that is from second place, so it will be 2. So it will act as 2 minus 1. The difference, it will give us 1. right? But in case it is 1 0, so 1, when you subtract 0 from 1, it will give us 1 only, and there is no borrow. We need not to borrow anything. In case of 1 1, the difference will be 0 and borrow will also be 0. So I hope there should not be any difficulty to understand this truth table, right? Now let's talk about the Boolean function of difference and borrow, right? So let me close this like this. Okay. So let's talk about the Boolean expression of difference D. Now if we look at here, because it is a very small truth table, so rather than going for K-map, we can just look at it. There are two places where D is high. So for this place, if you write, it is x bar y, or this second place is x y bar. And I have already discussed in my previous lecture that this Boolean expression is for XOR. So this is x XOR y, right? So now let's talk about the borrow. And the borrow is, there is only single place where borrow is high. So this is that place where borrow is having value 1. So, and here we are getting 0 1. So simple x bar y, we can write the expression for borrow. So this is the expression for borrow, and this is the expression for difference. Now to draw the circuit, it is very easy to draw the circuit for difference and borrow. So let's draw it. Let's say we are having x and y to input. So you consider this is x input, and I'm drawing it here. Okay, so this is x and this is y. If we want the complement of these, then we can take something like this. Okay, so we can take NOT gate here, which can give us complement of this thing. This will give us the complement of the first input. If we want the complement of another, so we can go for that, right? So this is x and this is y, and this will give us x bar. Now this is very easy to draw. So if I draw for D, D is having XOR. Let's take the XOR gate. Let's say this is the XOR gate. Right? So this, you take x and y input. So x is here. We can take x like this. So this is x input, and y input we can connect from here. So this will give us D as x XOR y. Now let's draw for borrow also. So borrow requires an AND gate. Now it requires x bar and y. So x bar is given here. So we can take x bar from this like this, and y we can connect from here. So this will give us borrow, and borrow is x bar y. So with this I am ending this lecture. In next lecture we will see full adder. full subtractor, right? Thank you.